Good morning, everyone.
Good morning, Anupma.
Good morning.
How are you this week?
It was hectic.
Sorry, what is it?
This week was hectic.
Work.
Yes.
Acha.
Working event today. Hey Anupama, morning.
Usually, this year end, unless you are into finance, usually the year end would be a holiday for everyone, isn't it? Or it's over. New Year is over. Christmas is over, so everyone started working.
No, nothing of that sort for our company.
Oh, okay. Where you work, Sindhu?
Innovate to Global Solutions.
Acha. So the clients are not.
Yeah,
Um,
they haven't taken the break, so we don't have the break.
Definitely. I hear you. Okay. Anyways, let's see what we'll cover today. So, what are the topics we covered in the last session? Anyone remember?
Basically about VPC, custom VPC.
VPC.
Yeah. So, mainly VPC and I haven't received, I don't think I received much. One or two hardly. The assignments. So, may I know the reason?
Anupama, my mother got operated, so I didn't got any time. Today also, I'll try to get much time to take the session. So that is why I wasn't able to. But
What about others? I received from Sunita. Yeah. Yes. I think.
It should not from I didn't do it, Anupama, be honest.
Oh, okay. So the assignment which I received is not from you? Oh, let me cross check.
Yeah, I don't think it's from me because even the same thing I couldn't get time. Really sorry. I think I'll have to try all these things now only this week. I've taken
Okay.
forcible break. So
Anupama,
this
I've sent
forcible
you 2 assignments. The third is I'm sending to the third and
Acha, fine. Okay. Tomorrow we will be doing another project, like little VPC, little like a VPC. So when it's like VPC, I'm talking about the complexity. So when we discuss about VPC, the understanding the concepts is little complex, but while we are doing it, it is easy, right? I mean, what I feel.
yes,
But
yes.
it's
The moment
other
you add that steps and all, after that it was quite deep.
okay. So for the project which we'll be doing tomorrow, it is other way around. So understanding the concept would be easy, but while doing, we will be having a lot of steps. Okay. But anyways, so folks, just try to complete it whenever it is possible, so that um, it will be difficult to forget faster if you do it hands on. If you do some sort of assignments like that. So it's for your good. I will not do anything with your assignments. It's for you. Okay.
sure, Anupama.
Yeah, just try to complete it, and like if possible, if you could do the certification, and you will be taking something from this training. Yeah. Anyways, let's start with today's session. Today's topic would be, just give me a moment, I'll check and let you know. So we have So we completed about the VPC, the databases, and R53 in the last session. Okay. So today we will be covering IAM, Identity and Access Management, the security management services, like what are the services which we have under security, and application integration services. Okay. So let's start with, I'll do this IAM at the end because I can give hands-on at the end. Okay. So initially, if I give, I may or may not have time for other ones. So let me start with security management services. Okay. So today's topics are quite simple only. You just have to listen, that's it. Huh? And if time permits, I will add a few more topics to give you a complete understanding. You will know like what I mean later. Okay. So first of all, let's start with the 6 pillars of framework. I'll share my screen now. So tomorrow we will be covering the ELB and auto scaling group. That's basically this week's agenda and the last week's. Okay. And even after the training, if you need any help, you're free to message me, not a problem. Okay. You're able to see my screen?
Yes. Yes.
Okay. Okay. So the 6 pillars of framework in AWS. So when you are creating an infrastructure or want to create an architecture in AWS, it is wise to follow these 6 pillars. Okay, include these pillars like the operational excellence, security, reliability, performance efficiency, cost optimization, okay, and sustainability. So previously there are only 5 pillars. AWS has added one more, which is sustainability. Okay, later, probably 1-2 years back. Okay. So this basically the 5 pillars, so the 6 pillars, it started with 5 pillars, as I said. It started with the white paper. Okay. So they just started with the white paper and then now it was a service. Okay. I mean, it is a service. So creating a software system is like constructing a building. If the foundation is not solid, structural problems can undermine the integrity and function of the building. The same way, when you're architecting, if you could neglect these 6 pillars, it would become challenging to build a system, okay, that delivers on your expectations and requirements. Yeah. So using the 6 pillars, usually the cloud architects, usually uses these 6 pillars to build secure, high-performing, resilient, efficient infrastructure for the applications. Okay. Now let's understand these pillars. So it's all about defining a pillar and then the design principles. Okay. So in the certification, you would definitely get a question from the 6 pillars. Definitely one question. Okay. So operational excellence. So as the name suggests, when you're building an architecture, you have to make sure it create the business value and the operations which you are doing it. See, for example, if you're going for a cloud ops, basically sysops or cloud ops certification, okay, so they concentrate completely on this pillar because it's all about operation. Okay, so making sure that you're operating well and creating a business value. Okay, so the operation should continue whatsoever the reason. And there are 6 design principles for the operation excellence in the cloud. Perform operations as a code. Whenever you're doing some sort of operations, do it as a code. Annotate documentation. For example, if you're a developer and if you're developing an application, your manager would be asking you to keep a document in parallel. And most of the time it will not be in sync, because whenever you change something in application, you forget to do it in the documentation. You update in the documentation, right? But in AWS, you can create, you can annotate a document for every build. You can automate that. Make frequent small reversible changes. Let's assume you are migrating. You're migrating an application or architecture to the cloud. Do it in small parts, not all at a time. Okay, so even if it fails, you can revert it easily. But if you're trying to migrate the whole thing, if it fails, the resources, the time would go away. Refine operations procedures frequently, because you have to keep on refining them. Anticipate failure and learn from all operational failures. Okay, so this can be done by like having a team meetings and discussing the issues. Okay, if we are all our team, if I have discussed with you regarding the issue which I faced, in future, if you face, you know how what to do, right? So you can learn from all operation failures and discuss about it. Next is security. So security pillar includes the ability to protect the information, the assets, the simple, like the architecture, the layers, like a network layer, the server layer, okay, a subnet layer. So security is all about having making sure that the users are authenticated to access the AWS services. And there are 7 design principles for that. Implement a strong identity foundation. So this can be done with IAM, which we will be covering today. Okay. Enable traceability. Monitor, alert, CloudWatch will be doing it. Audit, CloudTrail will be doing it. Apply security at all layers. If you take EC2, security group is a firewall for the EC2. Okay. Now this EC2 will be in a subnet. And for the subnet, you have NACL. So there are 2 layers of authentication, right? So apply security at all layers. Wherever there is a possibility, just enable the firewall. And automate security best practices. So if you are, changing or creating the services very rapidly, you have to make sure the security is applied to that new service also. For example, every day you create an EC2 instance, let's say you. Okay, so obviously you should be taking care of the security of the TC2 every day, because you're creating every day. So what you can do is, instead of manually enabling the firewall, you can just simply automate it. Protect data in transit and at rest. That can be done with encryption. And keep people away from data. This also can be done with IAM, giving the least privilege, giving only the permissions which is required. And prepare for security events. So are you aware of fire drill? Yes, fire drill.
Yes.
Yes.
Same way. So prepare for an incident by having an incident management process that aligns your organization requirements. Like, what if it breaches? So what are the steps to take care? Okay, so you manually breach it, and then you see what are the steps which involved in it. So you can experiment in AWS, basically, at a full-fledged way. Next, we have reliability. So reliability is basically, even if there are any disruptions, it should automatically recover. Okay. So to meet the demand and mitigate disruptions such as misconfigurations or transit network, it's all about backup of the whole architecture. Okay. So there are 5 design principles. Test recovery procedures. In the cloud, you can test how your system fails, and you can validate your recovery procedures. Automatically recover from failure. So we have covered RTS in the last week. And if you remember the multi-AZ part, your database will be in two different availability zones. So that if one fails, if a primary fails, it automatically fail over to the standby one. So automatically recovering basically means having a backup. Scale horizontally to increase aggregate system availability. So let's assume I have a server. I want more capacity, I would add to the same server. I need a RAM, I will add a RAM chip. I need storage, I will add disk. So if I am adding the hardware components to a same server, it's a vertical scaling. I'm trying to increase the capacity of a server. Now, if I need a more compute power, I will get one more server. If I need more storage, I will get one more server. So this is basically horizontal scaling. You're actually increasing the servers, small servers. So if you're adding a capacity to the same server, it becomes vertical scaling. But if you're increasing the capacity by adding multiple servers, it's called horizontal scaling. In both the ways, we're actually increasing the capacity only, but there are two different ways where we can do it. Now, if this server fails, all the users who is accessing this application in the server will face a downtime. But if a server fails here, you still have other servers up and running for time being. So scale horizontally for the availability, because if you go for vertical scaling, if it fails, it is not possible to access the server for that time. Stop guessing capacity. You need not worry about guessing capacity in the cloud. And manage change in automation. Whatever the changes you're doing in your infrastructure has to be done using automation. Like RDS is one of the automation, right? So failover, automatic failover. Next, we have performance efficiency. It's like I have an EC2 instance. This EC2 instance is capable of 100 users. It can handle 100 users. Even if you have 101 users or 105 users, the performance would be degraded, isn't it? You take your phone. If you're accessing your phone beyond its capacity, it impacts your performance. So making sure that whatever the services which you are having it, are they performing well? Is all about this pillar. Okay. So what are the design principles? Democratize advanced technologies. It's like this. If you take the latest technologies like AI, a blockchain, okay, or data analytics, whatever, the recent ones, the emerging technologies. Okay. So if you go to market, you may not get many people. I'm not denying the fact that we still have people who can work on this, but we don't get much people who are experts in it, having 10 or 15 years of experience. Okay. So what AWS is, push that complexity to us. Because if you, for example, if you need to go for blockchain, first of all, you have to create the infrastructure to have a product on blockchain. Isn't it? So what AWS says is, push that complexity of creating the infrastructure to us. We will take care of the infrastructure underlying. You concentrate on your product. Okay, because AWS is taking care of the infrastructure, performance is guaranteed. Go global in minutes. And use serverless architecture. You take Lambda. So when compared with EC2, Lambda is serverless because the underlying servers will be managed by AWS. Even if there are some millions of invocations, the Lambda would run million times. Because the underlying compute power would expand and shrink back automatically. But if you take EC2, it is not serverless service. Because you manage it. You manage the instance type, for example, T2 micro. Okay. So if you're using serverless, whatever it may be the request, AWS will be taking care of it. But if you take EC2, if you are going for beyond its capacity, obviously you will have performance issues. Experiment more often. That is the reason we have a free trial. And mechanical sympathy. Mechanical sympathy is using the right service for the right use case. Okay, let's assume I have 10 EC2 instances. Now I need to access a common volume for the EC2 instances. These EC2 instances are in a region in different availability zones. Now, which service can I use for the volume? Ideally. If I have 10 EC2 instances, I need to access a common volume.
DFS.
EFS. Superb. Now let's assume I haven't covered EFS service. Then what is the other service you think of? Hello? What is the other service you think of? Yes, Manjali. Try. Sorry?
S3.
S3. Perfect. Now I haven't covered S3 also. And what is the other service? And the only service which you can think of? What is the only one which is left in the storage services which we covered?
EBS.
EBS. So
But
EBS
it would
not
be
a
within
shared
the
volume.
right?
I'm coming to that. So EBS is not a shared volume. If you have a different availability zones, what you need to do? You need to create 10 EBS volumes in different availability zones, and you need to assign each volume for each EC2 instance. Is it an efficient way of using it? Definitely not. Now, just because you don't know that S3 or EFS exist, you think EBS is the right volume because that's the only one which I taught. Let's assume. Okay, so this is what exactly the mechanical sympathy is. So if you are not aware, it's just that it's not that it doesn't exist. It's just that you're not aware of it. So it is because you're not aware, you may think whatever you know will be the solution for a use case. So this can be solved by knowing the services, as simple as that. As an architect, at least you should know, okay, what services will do what. At a high level, very higher level. Like, see, EFS or S3, very higher level. That is called mechanical sympathy. Okay, so finding the right storage for the databases, if it is a structured RDS, unstructured DynamoDB, for caching, elastic cache, these are all mechanical sympathy, using the right service for the right use case. See, what happens is usually lack of knowledge. People may end up using wrong service and they say the database is not good enough. Yeah, it happens. Next, we have cost optimization. It's all about delivering the same business value, but with the lowest price point. Sorry. There are 5 design principles for that cost optimization. Adopt a consumption model. So we have a lot of services in AWS where we can manage the cost, the billing dashboard, the cost explorer, the budgets. Okay. So the usage, cost and usage reports. So we have different tools where we can manage the cost, where we can manage it, control it, etc. Okay. So adopt a consumption model. Pay only for the resources that you require and increase or decrease based on demand. As simple as that. Because we have the flexibility in the cloud. That flexibility is available in the cloud. Measure overall efficiency. Measure the business output of the workload and the cost associated with it. Stop spending money on data center operations. Whatever you do it in on-prem, you can do it in the cloud. So you need not again invest in data centers. Analyze and attribute expenditure. So as I said, using those tools, you can analyze it. You can analyze and attribute the cost. And use manage and application level services to reduce the cost of ownership. So this is like this. EC2 over RDS. So in RDS, the operating system, the volumes are managed by AWS. Now you can concentrate only on your database. So you can reduce the cost of ownership by using the managed services or application level services. And finally, we have sustainability pillar. So the sustainability pillar is all about the impact which we make to the planet Earth, to the environment. Okay. So even if you spin a small server, a one CPU, an vCPU, an EC2, which has a T2 micro has having one vCPU. Even if you run a small server, it still has an impact to the environment, isn't it? Maybe minute, but still have it. Right? So every time you launch an EC2 instance, you are making some impact. Okay. And once you work, then yeah, you can just terminate it. But if you don't terminate, unnecessarily, you're actually making an impact to the earth. Okay, it's like this. If you remember, I spoke about this. If I have an EC2 instance of T2 micro 1, you can run 24/7 for an year like that. Because you can run an EC2 instance for 750 hours per month. Okay, and you can do it for 12 months like this. But because you're not physically seeing the cost, okay, if you try to launch it and you keep it idle, you're actually making an impact indirectly to the planet Earth. Okay, that is the reason I always say, please do the cleanup. Always I say that. In terms of you avoiding the cost as well as understanding the environment impact. Okay. So there are 6 design principles. Understand your impact. Maximize utilization. So if you're using a server or basically a service in AWS, use it completely, efficiently. Okay. Use managed services. See, AWS is not saying not to use. Whenever you're using it, use it completely. And if you're done, just give it back to AWS. Use managed services because underlying AWS will be taking care of it based on the need. Reduce the downstream impact of your cloud workloads. Reduce the amount of energy or resources required to use your services. Okay, that's about the well-architected framework. Now, initially, when you are actually creating an architecture, yes, you could follow these pillars. But over a period of time, it might be difficult to understand whether the whole architecture is based on these pillars or not. That's where you can use a AWS well-architected tool. Okay, so here, first of all, you need to define all your workload information. You will have a series of questions, a lot more questions. Basically, you'll have a lot of questions. Okay, so where you need to, first of all, define it, give an understanding of your review to this tool. Okay, so that based on your answers, for example, there are 6 pillars, right? Now you can define your priority on these pillars. See, for my application, for my workload, cost optimization is the main priority. Or security is number 1 priority for me, and then cost optimization, and then performance efficiency. So based on the priority, the well-architected framework tool evaluates and give you some reports. Okay, and it will give you some sort of recommendations, and based on that you can reconfigure your resources. Okay, next we have cloud trail. So let's assume there is a data breach or it's a breach in a project. Need not be data breach. Okay. Now, usually the manager would be asking, what happened? When did this happen? At what time? Okay, who did this? Yeah. And what is the impact? So in AWS, CloudTrail is the answer for all these questions. Okay. So CloudTrail captures the activities happening in your AWS account. CloudTrail captures the activities happening in your AWS account. Means if someone launched an instance, someone deleted a VPC. Okay. Or even if you log into your AWS account, the CloudTrail will capture that. Okay. So from last week, I don't have any sessions because of this vacation. Now you see my CloudTrail. Just give me a moment. I'll log in and show you. So CloudTrail is enabled by default when you create an AWS account. But you have till some limit it is enabled. Okay. So you can see it in the event history. You see. So we are discussing about databases, isn't it? Yeah. So when we're discussing about a databases in the last session, we spoke about creating an RDS and creating an EC2 instance and connect to it. Okay, this is about deleting it because the last thing which I did was deleting, isn't it? And then we create it and then we delete it. So terminate the instance, run instances, create a database, terminate the DB instance. Okay, so we spoke about VPC peering also. And even the console login. So I logged in at this time. Okay. And usually the events will be in JSON format. The events or logs. Okay. So this account ID. As a root user, I'm trying to log in at this time. This is the source. The event is console login in this region from this IP address. The login was successful. It didn't throw any error. And few more details. And of course, I just have shown you what are all the things which we already discussed. There are a bunch of details also, like type of event, the MFA. We will talk about it a little later. So each and every event will be looking something like this, giving information about that event. Okay. And the event history will have the last 90 days of data only. And that too, only specific events. Okay, so you can see the last 90 days of data and you can even download it in CSV or in JSON format. Okay. And the last 90 days data of the management events. There are types of events in CloudTrail. So by default, for free, AWS CloudTrail enables or captures only the management events for the last 9 days. But what if you want to actually have the list of records from more than 9 days? Then you may need to create a trail. You need to create a trail. Okay. Now, when you're creating a trail, you have to show a place where you can store the events or the logs. Okay. So S3, this CloudTrail supports S3, where you can create a new bucket or choose an existing one if you already have one. If you want to enable the encryption, you can do that as well. Okay. You can also go for cloud file validation. Like if someone has modified, see, it is storing into S3. Okay. Now, the cloud file validation will not allow any modifications to this S3 bucket if you enable it. You can have a notification. You can go for CloudWatch logs. So irrelevant. So what I'm trying to say is you can simply create a trail and you can define a bucket where you can store the trails. And you can define also what kind of events, whether you want to go for management events, data events, or insight events. So management events is like a management operations, like as I said, creating an EC2 instance, creating a VPC, creating a subnet, deleting them, even the console login. These are all the management events, the API activity. So you can define whether you want to go for read, write, you want to define some the encryption events also, exclude ones. Okay, so these are all the things which are supported under management events. And you can also enable data events. Data events all about the operations happening, the activity happening within a service, within a resource. Okay, so someone has deleted my object. Someone has accessed an object, a put object, uploaded an object. So the activities happening within a service will be also captured under the data events. Previously, AWS is supported only S3 and DynamoDB. No, S3 and Lambda. Later, they have added all these services. These are the data events. It's not supported on all services, only few, as you could see the list. And finally, insight events. Insight events is basically the unusual activity. The insight events capture the unusual activity happening in your AWS account. Like every day from 9 a.m. to 6 p.m., I would be accessing my AWS account. All of a sudden, at 1 a.m., there is a login. It is an unusual, right? Usually, I don't access it at the time. But because of my work, if I log in at 1 a.m., it will capture under the insight events. This is unusual, not usual. Okay, so you can enable all or you can enable only one, not a problem. And you can just go and review it and you can create a trail. Okay, so AWS will cost us. That is the reason I'm not creating a trail, but this is how you create a trail, as simple as that. So CloudTrail captures the activities happening in your AWS account. So if you're trying to access through console or CLI or SDKs, in whichever way, through whichever platform, if you access it, it will capture. Okay, so those events can be used to view, download, archive, analyze, respond it, etc. And then you can create 5 trails per region, and it's a hard limit. It cannot be increased. So discussed management events, the management operations, also known as control plane operations. Data events, the operations, the activities happening within the resource, also known as data plane operations. Insight events, unusual activity happening in your AWS account. CloudTrail event history, like the last 9 days of data. And organization trails. So before I talk about organization trails, I need to talk about the AWS organization. Okay. Z or S, anything is fine. So let's assume I have a project in my company. So I have an AWS account. Have another project on another AWS account in the same company or organization. Now I have a project where they have a dev environment, a prod environment, and test environment, and they want an AWS account separately. So under a third project, they have 3 accounts. So if I have n projects, I may have n accounts, isn't it? Yeah. So when we say accounts, there should be a management of the accounts, isn't it? Like, every month AWS will generate an invoice for whatever the usage. So you will have billing on monthly basis, right? And each and every project or client will have their own kind of a compliance regulations, which we need to make sure applicable for those accounts. Yeah. So initially, when you have less accounts, that's fine, you can manage it easily. But over a period of time, when the number of accounts are increasing, it becomes tedious to manage those accounts, right? Because, for example, each and every organization will have, as I said, like kind of compliance. So whenever there is a new account, you should be making sure that it's applicable for that. You have to make sure that account is under the compliance, is being set like that. For each account, you have to do it. So redundant work is there, isn't it? And if you miss one, yes, there is a possibility that you may miss one, because if you are having multiple accounts and you have to manage a team who would be managing your AWS accounts every month, the billing and etc. Okay, so to avoid that, what we can do is we can use AWS organization. Okay, so in AWS organization, what you do, you create an account like any other AWS account. You create one account, and this account will become a master account, because you would be adding all these accounts under this. Oh, okay. So all these accounts under this. So these accounts will become the member accounts. So what you need to do is, first of all, this master account will request it and the member account will accept it, so that the connection will establish. These are called the member accounts. Okay. Now, if you have a project having multiple accounts, you can add them under one OU, organizational unit. And you add this OU under the master account again. So instead of adding directly under master account, you can have a OU or an organization unit, and you can add these accounts under OU. Now, the advantage is that because you have multiple accounts, under this account, under master account, whatever the policy, basically the permissions which you apply to this master account is applicable to all member accounts. So organizational compliance, the regulations can be applicable to all accounts under that organization. So you define a service control policy, an SCP, to the master account, applicable to all member accounts. Now, there would be few policies which would be applicable only to a project. So you can add them under one organization unit, and you can assign this SCP to an OU also, possible. Or you can explicitly assign a policy to an individual member account also. So we can manage the permissions using SCP, service control policies. And AWS organization is all about adding the member accounts under one account with a master account. That is AWS organization. Now, The organization trails are, see, whenever there is an activity happening in your AWS account, you can enable the cloud trail and you can define an S3 bucket. If you wanted to know the activities happening in all AWS account, you need to enable the cloud trail in all accounts and they have their own S3 bucket. So if I have n accounts, I'll have n S3 buckets. Now, instead of that, if you enable the organization trails, what are all the activities happening in all AWS account will be captured in one single S3 bucket. Of course, they are not mixed up. They have their own way of a partitioning of the logs. Okay. So if you just want to analyze something, this is a single source of truth where you get everything. Okay. So that is organizational trails, basically managing the events from multiple accounts. Next, we have CloudWatch. CloudWatch. So it's like a CC camera. It just watches the cloud services. Just watches. And what it does? It creates metrics. Some graph, statistics for the metrics. Okay. So CloudWatch is a monitoring service. It will collect the metrics where we can monitor them. Based on it, we can act and also analyze it. Okay. So if you have CC camera, you feel so comfortable seeing like by seeing what is happening around, isn't it? Wherever you have it, wherever it is required. The same way, by having a CloudWatch, you would know what is happening with an AWS service. And it will create or collect some metrics. Okay, so how does it work? So either from AWS services, which uses CloudWatch, or from custom data, CloudWatch will gather the metrics. Okay, the best example is the CPU utilization of an EC2 instance. It's a metric. So CPU is a metric. So if I have multiple EC2 instances, one of the metric of CloudWatch is CPU in EC2 service. So it will gather the metrics. Now these metrics can be seen as statistics, either from your console or from a third-party interface. That's one way of looking into the metrics. And another way is, so once it gathers a metric, okay, you can monitor. Monitoring is looking into the statistics. You can act, that is CloudWatch alarm. So it's like this. I have an EC2 instance. And if the CPU utilization of the EC2 instance is greater than or equal to 80%. Okay. I wanted to know. So ideally, if you have your local machine, you can check your local, your machine CPU utilization by using a task manager if you're using Windows. If it is a Linux, some commands. If it is a Mac, again, a manager kind of, right? Same with EC2 instance, because EC2 is also a virtual machine. But without accessing the EC2 instance, if I need to monitor the CPU, CloudWatch. Okay. So you may need to monitor the CloudWatch dashboard in order to understand the CPU utilization. But if I have hundreds of instances, I cannot check hundreds of this CPU utilization metrics every time, right? Isn't it? You cannot see 100 metrics all the time. Not possible. That's where we have a CloudWatch alarm. Like whenever a CPU crosses a particular threshold, I wanted to get an alert. So what you can do, you can create an alarm. So if you create an alarm, what happens is in the CloudWatch dashboard, you would see that there is an alarm. It turns red, basically a metric, something like this will turn red. So you can clearly visually see it. Even further, you need to monitor the dashboard, isn't it? So you have to make sure you're monitoring the CloudWatch dashboard to see the alert also. That also may not be possible every time. You cannot see the CloudWatch dashboard all the time. What you can do is, you can furtherly integrate this with SNS, a simple notification service. Okay, so that you will be getting notified, for example, to your mailbox or to your mobile, anything. You'll get a notification. So at least you should be alert in checking your mailbox or checking your phone. You can furtherly extend this alarm saying that whenever CPU crosses 80%, I wanted to integrate with auto scaling group by adding another EC2 instance. So now it automatically scaled by adding another EC2 instance. So on a single metric, okay, on a single metric called CPU, you can create an alarm. So alarm means based on some threshold or condition, alarm would be triggered. Okay, now you can create an alarm on a metric. Now based on the alarm, you can define different actions. Action 1, action 2. Different actions. So ideally, CloudWatch works like this. It will gather the metrics. Based on the metrics, if you want, you can create an alarm, or based on the metrics, you can monitor them. Now, when you're creating an alarm, you can define actions. See, alarm alone will not do anything unless you integrate and define actions. Hoping it's making sense.
Yes.
So yeah, very much same as what I said. On a metric, you create alarms. You can create multiple alarms. And on a single alarm, you can define multiple actions. So when I say alarm, you have three possible states. One is okay. Like if the CPU, sorry. If this is my alarm condition, if the CPU utilization of the EC2 instance is always below 80, it will be an okay state, isn't it? If it crosses, alarm state. But when you are creating an alarm itself, if you haven't given proper information, it will move to insufficient data. Okay. So if your information is not available, it will move to insufficient data. It's one of the example can be have an EC2. I created an alarm, CloudWatch alarm. Okay. Now later I terminated this instance. Now the alarm will move to insufficient data because it doesn't have a metric to monitor it. Okay. Now when you are creating an alarm, you can define when to trigger, when to invocate an alarm. You can define using the data points. For example, you see, for every 5 minutes, I wanted to monitor the CloudWatch. Period is 5 minutes. So this is basically the time period is 5 minutes. Okay. Now, I want to invocate the alarm for 3 data points. Means, if you see here, this is the actual graph. Okay, this is a threshold I have kept. The blue one is a threshold. The red one is basically the value of that metric. Now I want to invocate the alarm if it crosses the threshold for 3 data points. For 3 data points means for 3 periods continuously. So if you take this, if you see here, the value crossed the threshold, okay, and it was there for consecutively 3 data points. It crossed the threshold for 3 data points, means for 15 minutes, I can say. Action is invocated. Means the alarm would be triggered and the action will be invoked. Now, if you see the second scenario, same, the value crossed the threshold, okay, but it was there only for 1 data point, means only for 5 minutes around, like in between, you have this, it spiked, crossed the threshold. And by the next data point, it was down. So, no action is invocated. So you can, even though you are actually creating an alarm, you can define, see, sometimes what happens is when you launch an EC2 instance, suddenly there might be a rise, but maybe after some time it will adjust. So you may not want to add another EC2 instance for that, or you don't want a fake alarm. It's not fake. I don't know what to say, which term I can use. You need not worry about a few alarms, right? Even like a fire drill. Okay, so it is not required to take an action on such kind of spikes. So what you can say it if it is there consecutively for 15 minutes. If you keep 2 for 10 minutes. If you keep 1 for 5 minutes. You can go for furtherly also. Okay, so that's about the security management services. Any questions, please?
Are we going to implement CloudWatch?
Sorry, come again.
Are we going to implement it also?
The CloudWatch one, you will be doing the hands-on. Yes.
Great.
There is a guided lab which you can do it. I'll tell you.
Mhm. Actually, I tried to set a CloudWatch for my console, but certainly I got charged 3 rupees and 33 paisa from AWS. So I'm just worrying about it.
You got charged this week for this course?
No. For my certain things, I said this
Yes, please.
sort of 80%, but I don't know how to make it stop using the service when the threshold reaches. So there is a problem that I'm suffering with.
So you have an EC2 instance.
Mm-hmm.
So you want to create a threshold.
Yes. And I just want to know how to.
That you have to furtherly integrate with SNS, for example, because SNS is also free. See, just by creating a CloudWatch alarm, as I said, you just see an alert in the, or you just see that alarm is a metric is turned red in the dashboard. But for that, you have to monitor the CloudWatch dashboard as well. To avoid that, what you can do is you can furtherly integrate with SNS so that you can get a notification to your mail. See, mail is something which we usually check every day. Correct? No?
Yes, yes,
Mm.
yes.
Mm. So furtherly, if you could integrate with other service, yes, then you would know it. Okay, there is an alarm.
Okay.
Mm. So the alarm which we will be creating is a billing alert. We will be creating a billing alert. Like if your billing crosses $0, you would be getting notified to your mail. There is an alarm which we'll be creating as a guided. You will have a guided steps in the lab doc. Okay.
Done.
Guys, a minute, please. I'll just give me a moment, okay?
Sure.
So, application integration services, SQS, simple queue service. Um, if you have microservices, you're aware of microservices? Hello?
Are you asking for that micro and monolithic?
Hmm.
Yes, a little bit glimpse is there.
Yeah.
So, in microservice, we have dependency on one. For example, if we are doing, if we are deploying an application, and we are creating two EC2 instances, one for application and one for its data. So I hope I am not wrong. Uh, in this deployment, we do have dependency on these two EC2 instance only. That is why it is a microservice. For example, Docker. I hope Docker is a microservice in which we do containerization, and then we do not have dependency upon whole, but we do have parts. So if something went wrong, then one part is stopped, but other services are continued. But in monolithic, we do have dependency on one only. So see, you have given an example of vertical and horizontal scaling. So if I give an example for this, then vertical will be for monolithic, and this microservice will be of uh, horizontal scaling.
Mm. Yeah, very much same. So, if you take an Amazon shopping application, you would have a profile service where you can create a profile and log in. You will have a products page where you will be accessing the products. So you'll have a specific code for that. And once if you like a product, you'll add to cart. There will be a cart service will be working to hold your products. And then payment. Ideally, let's assume you have these parts in the application. So previously, when developers used to develop an application, they used to write the whole code. Even if it is very complex, you write everything in one single file, everything in one single file. Probably like divisions are there for other ones, but you will have a single place where you will have whole code. Okay. So if there is an issue or if there is a need of update or upgrade for a single service, for example, I wanted to update my code for payment, the whole application used to be down because everything is dependent, tightly integrated with each other. Or if there is an issue with product page, people who are accessing the products. So again, the whole application used to be down because they can't access the cart or payment even if there is an issue in one service. Okay, now if you go for bigger applications, you'll have a lot of services like that. Now to remove the dependency or to create the independent, to make them independent, microservices are introduced. Okay, so these are all small parts of the code. Okay, so these are separated. They are loosely coupled. Okay, so that if there is an issue in one of the service, it will not impact the other services. Even if there is an issue in the products page, they can still do the payment for the products. Or if there is an issue in the payments page, they can still browse the products and add to cart. So they are loosely coupled. After introducing the microservices, these services are isolated. Okay. Now, why we're talking about this now? SQS is used to define or is used to communicate between the microservices. The communication between the microservices can happen using SQS. SQS, excuse me, will have it's like a queue, like a pipe, where you'll have a producer, like one microservice, a consumer, another microservice. So whenever you add a product to the cart, definitely there should be a communication between the services, right? So using the queue, it would be added to the cart. Okay, so one of the example of SQS can be, it is used to communicate between the microservices. Another example can be Swiggy. You are aware of Swiggy, right? So you'll have multiple restaurants. And you will have a Swiggy application. You will have some thousands of customers, basically millions. Okay, so there will be a queue for each restaurant, let's assume. So using a Swiggy app, the customers would place the orders. Now let's assume the customers are placing order to this restaurant because it's like very much popular or something like that. Now these orders are placed basically using a SQS. Okay, so the Swiggy uses SQS and the orders are as like the messages to the queue. Now the restaurant has to pull if there are any orders every time. So SQS is a pull mechanism or poll mechanism. Means the consumer has to pull the messages if there are any kind of. So the restaurant every time has to refresh and check if there are any orders. Okay. Now in SQS, you can also define like whether you wanted to preserve the order. For example, the customer 1 first placed the order, and then the customer 2, second order, and then the customer 3, and then the customer 4. So you have types of queues in SQS. One is standard, other one is FIFO, first in, first out. In standard, the order is not preserved. The customer 1, even if he placed first, it may not be the third, it may be the third order. But in FIFO, first in, first out. First in, first out. So it preserves the order. So you can define that way also. So it's fair, right? The person who orders first should be delivered, should get that order first, right? Deliver the order first. So you can define the order also. Okay. So the same with other restaurants as well. So another example can be, yes, Swiggy. Yes. So this is also a serverless service because you don't manage the underlying servers. Okay. So it is secure, durable, available. I'm sorry. And another thing is, sorry, I forgot. You can define till how much, how long the order can be there in the queue also. For example, if you order in the morning, it cannot deliver in the evening, isn't it? It has to be done in the morning itself. So you can also define the time period. The message can be there in the queue. So probably 1 hour or 1.5 hours or maximum 2 hours, depending upon the distance. Okay. So in SQS, we can define the messages that, like the how long the message can be there. So in our application in Swiggy, you can keep 1.5 hours, for example. But the maximum time the message can be there in the SQS key is 14 days. 14 days is the maximum. Okay. So SQS is secure, durable, available, hosted queue that lets you integrate and decouple distributed software systems and components.
Sorry, Anupama, to interrupt. What is the time it will reside there? Maximum time? Sorry, I missed the slide as well.
14 days, ma. 14 days. I
Okay.
haven't covered that. I'm just giving an example.
Sure. Thank you.
I'll show it in the slide also. So the maximum time the message be there in the SQS queue is 14 days. If no consumer consumes it, okay, it can be there for 14 days max. So you need not worry about managing the messaging middleware. It eliminates the complexity. You can send, store, receive message at any volume without losing messages. Yes, in SQS, there is no way where you would be losing a message. Okay. So understanding the parts, you have distributed components, the queue, the SQL servers basically, and the message itself. If you see the messages, each and every message is redundantly stored in multiple SQL servers for high availability. As I said, there you will not be losing any message in the queue. Okay. So if a server fails, your message is still available in other SQL servers for high availability. Okay. Now let's assume a component 1 sends a message to the queue. Now he can define for how much time the message can be visible to the consumer. Okay. Now when a message was sent, first of all, the message is redundantly stored and the consumer has to consume the message within the time. And the consumer has to consume it and delete that message in the queue so that duplicates will not be introduced to avoid the duplicates. Okay. So you can send unlimited number of messages depending upon the queue you use. and maximum message size can be 256 KB. But if you want to send a message more than 256 KB, you have to use S3. You can extend your message size by using S3, where you can go maximum of 2 GB. Even if you use S3, maximum is 2 GB only. And there are two types of queues, as I said, standard and FIFO. So standard, with the help of standard queue, you can send unlimited number of messages. But in FIFO, you can send only 3000 messages per second, but you can raise a request to AWS for increase in the limit. Okay. Now, at least once delivery, occasionally more than one copy of message delivered. So you ordered in Swiggy, you got the order first, and you got the order second time also, but you ordered only once. This happens if they use a standard queue. So at least once delivery, definitely it will be delivered once, but occasionally, not all the time, occasionally more than one copy of message delivered. Have you got any Amazon delivery twice? They might be using standard queue. Next, FIFO. FIFO is exactly once processing. It is sent, received, that's only once, exactly once. And also the order, as I said, best effort ordering, it may not be following the order, but in FIFO, first in, first out delivery. Next, we have SNS. So we spoke about the Amazon microservices, like basically the application where you will have a profile, a products, cart, the payment. I said the communication between the microservices can be done using SQS, right? Now, once you've done the payment on an Amazon product, okay, you will start getting notifications like your order is placed and it is shipped, it is in transit and then delivered. So these notifications you can get using SNS, a simple notification service. Mobile push notifications, for example, if you have any updates for your Android, whatever, if it is Android or Mac, whatever, you will be getting a notification at the top, right? Like you see there is an update to install, do it now, already now, whatever. So that also can be done using SNS, mobile push notification. Okay. I mean, these are the real-time scenarios where we use SNS, but in AWS, is, as I said, like if a CloudWatch alarm is triggered, you want to get notified, a threshold is breached, you want to get notified, you can use SNS. Okay. So you have few similarities in SNS, or basically, I would say the difference between SNS and SQS is this. One major difference is in SQS, you say producer and then you say consumer. Even in SNS, this is basically an SQS queue. In SMS, in SNS also, you have a producer, you have a consumer, or you also say a publisher, a subscriber. So SNS can be used as a pub sub also. So in between, you will have a topic. You have a topic. A topic is a communication channel between the producer and the consumer, or publisher and the subscriber. For example, another example can be if you are looking for a job in a particular company, you go and subscribe to the job alerts in their company's website, isn't it? So that whenever there's a job posting, you will get notified regarding the same, isn't it? So there also you can use SNS. Okay. So SNS is highly available, durable, secure, fully managed PubSub messaging service. It provides high throughput, push-based many-to-many messaging. with the help of SNS, not only that you will get notification to your mail or phone, it can also integrate with multiple AWS services like Lambda or SQS itself or HTTPS, etc. And SNS is a push mechanism. So whenever a publisher, whenever an event occurs in publisher machine, it triggers SNS, and SNS will push notifications to multiple subscribers. Here also you can see that. Multiple subscriber endpoints. Yeah. So a topic is basically a communication channel. In order to start with SNS, the first thing which we do is creating a topic. And then you add this SNS topic as an event in the publisher. And then you subscribe with this endpoints in the SNS topic. So that this integration would happen. Okay. And another example can be an S3. So I want to get notified to my mailbox, basically, whenever an object is deleted in my S3 bucket. So delete event. Now what I can do is, if I want to get notified, I will create an SNS topic. I will add this SNS topic as an event in the S3. Like you will have a feature in S3 called event notification. If you remember, we discussed this in S3. Event notification feature. So in this feature, using this feature, you can add this SNS topic as an event in S3. And you can add the email address as a subscriber in the SNS topic. So that whenever an object is deleted in this S3 bucket, I will get a notification to my mail. Okay, another kind of example. Okay. Next, we have Kinesis. Kinesis is basically used for streaming. Okay, in real time. So when we talk about analyzing any data, for example, so first of all, if you need to analyze some data, the data has to be created and it has to be stored on some storage service like S3. And top of S3, you will analyze it. You will run some tools and you analyze the data, or logs in CloudWatch logs also. So before you analyze, first of all, the logs has to be created and then you start analyzing it. But Kinesis is basically analyzing at a real time. By the data, your data has not been created completely. So while it is processing it, analyze it, and it does some operation to store it in the consumers, or basically the endpoints or downstreams. Okay. So with the Kinesis, you can ingest real-time data, videos, audios, logs, websites, clips, website click streams. Another example can be if you are trying to if you have observed in Facebook Shorts or YouTube Shorts or YouTube videos also, or Facebook videos, if you are watching a video continuously, continuously means completely, I mean to say, you opened a video and then you're watching it. And if you're watching almost 75%, then the below videos would be automatically aligned according to the, depending upon the video you watch. For example, if you're watching some devotional one, you'll get relevant ones down. Have you ever observed that way? Or even YouTube Shorts? Yes.
You mean the suggestions we get as per the watch history?
Not suggestions. Not exactly suggestions is something where it will tell you these are the suggestions kind of. But if you open our YouTube videos and all, okay, those are the suggestions or
Yeah, that is called suggestions in YouTube.
Yes, you must watch it.
Probably. So maybe it is called suggestions. I've never, I don't remember seeing it. Okay.
You can see it as a monopoly.
This is basically on top of my mind, so I just thought of saying it. So while you are watching a video, it automatically analyzing at the back end and it is giving you the relevant videos below. Okay, that means it is analyzing at real time, isn't it? Based on the click stream, like where you basically you clicked on a particular video, and then based on that it analyzed it like using machine learning or whatever, and then it is giving, okay, as you said, maybe suggestions. Maybe you can watch this kind of. Okay. So I'm talking about if it is a real-time analyze, that is example which I can use. Okay. Now Kinesis is basically used to analyze the real-time data. And we have 4 types here. Kinesis video streams, data streams, Firehouse, data analytics. So video streams is, it will stream videos. For example, if you're looking, if you see live, YouTube live streaming, Facebook live streaming. Okay, so someone is streaming in live and you can see it from public internet, isn't it? So they can use Kinesis video streams, or you can have an EC2 instance to analyze something, or you can see it either from the public internet. One of the examples is live streaming, like YouTube live streaming or Facebook live streaming. Kinesis data streams. So Kinesis data streams not only ingest from one source, it will have multiple producers or multiple sources. Okay, where the data would be stored in shards. And at the other end, you will have EC2 instances which will be analyzing the data and will be sent to the destinations, basically the storage services. Okay. Next, we have data firehouse. So data firehouse is all about loading the data, loading the streaming data to the data stores. Okay, so here also you can use firehouse. Loading the data into data sources. So sometimes it may not be possible to directly store to the data sources. You may need to use Kinesis Firehouse. Next, data analytics. You can get the data either from the Kinesis stream or Firehouse or from S3 bucket. Okay, the data can be an input to this data analytics. Okay, so what this Kinesis data analytics will do, it will continuously read and process the streaming data. And while you are doing it, you can process the data using SQL queries. Okay, so you can run SQL queries and you can produce output to store it in other services. Okay, so the one which you need to remember for the exam is the types of Kinesis. It's basically ingest real-time data kind of. The Kinesis ingest real-time data. Okay, the types of Kinesis like video streams for videos, data streams for data, Firehouse for loading the data, and analytics is for running SQL queries while analyzing. Okay, that would be good enough. So this was recently added in the exam. Next, we have step functions. Okay. It's an orchestration tool. Okay, let me directly go to the example for better understanding. I want to create a bank account. Yeah, a new account in bank. So what I can do is I can create a step function. It's basically a running different processes. For example, in this example, if I start a particular step function, you have two lambda functions which are running in parallel. One is checking the name, other one is checking the address. Once they are validated, you will create a new account. That's it. End. So serverless orchestration tool means you can integrate multiple lambda functions to make a solution, to create a business solution. Now, do I need to use a step function for that? Can't I individually manage the lambda functions? Definitely you can use it. But if you want to automate the whole process in a single workflow, in a simple workflow, you can create a step functions. So as the name suggests, so step functions is a serverless orchestration service. So not only that you integrate multiple lambda function, you can also integrate with other AWS services also to create some business critical applications or so. Okay, so these step functions is based on the state machines and task. So for example, in step functions, a workflow is called a state machine. So this is basically a workflow. So this is basically called as a state machine, the whole thing. Yeah, which is a series of event-driven steps. So event-driven step means when you switch on a fan, if you switch on if you power on a switch, okay, to use the right word, the fan would on, right? So it's like when you start a step function, it's an event to this two lambda functions. So event-driven steps. So based on an event, it run. Okay. So a workflow is called a state machine, which is a series of event-driven steps. Each step in a workflow is called a state. So this is basically a state. And a task state represents a unit of work that another service such as Lambda performs. So task state means it is doing some operations, a task. Now a task state can call any AWS service or API. So as the one Lambda is calling another Lambda function, so you can call any AWS service. Okay, so let's extend this use case with human approval. So the same thing, we just extended it. I started a workflow where it is checking the name and checking the address. So if a review is required, so is review required? If I go for yes, so a notification will be sent to the approver using SMS. So now you see the state, the task state is calling based on review, is calling another AWS service. Now the person should review it and then he should say yes, approved. If it is approved, yes, approve application. If it is approved, no, reject application. End. Even if it is approved or reject, it will be end. Now, if the review required itself is no, it will approve the application, it will end. So you can add few more. You can extend your architecture by adding different services and all. Another use case. Let's assume you subscribed to Netflix and that subscription expired. Okay. So there is a service called Event Bridge where it will save the events. Okay. Now let's concentrate on step functions. Now, whenever a subscription event occurred, it triggered step function, means now you are calling this workflow. Now, when you call it, the step function will start it. Now, when you start, there are two Lambda functions running in parallel. So let's assume your Netflix was expired. So what it will do? It will suspend all the services, all the resources, like you cannot watch the series or movies anymore. Right? And one another Lambda function will email the customer. Definitely, right? See, your subscription is expired. If you want to continue, please renew it, kind of. Now, put an event in the event bus. Again, an event bridge will come. And another event will be stored. But in the step functions, it will end. So now, these Lambda functions are invocating another service called event bridge. Okay. So any questions, please?
No.
So I have a question regarding CloudTrail. It uses the S3 or that requires a storage, right?
Correct.
Okay. And in CloudWatch, we don't.
You have CloudWatch logs.
Logs.
So where it has its own way to store the logs.
But that should be limited or
No. There is nothing as such.
Okay.
Yeah. Any other questions? Okay. So before we start with IAM, let's go for a break. Okay. And post break we'll see IAM and then we'll see what can be done based on the time we have. Yeah. Happy break, folks. Hi, 7 back.
Yes.
Okay, cool. IAM. IAM stands for Identity and Access Management. Let's assume there is a project, an AWS project, and this project is using multiple AWS services. And obviously, in order to implement the project, there will be an AWS account. Okay. Now, like any other account, like, when we started with the program, we created an AWS account, right? So the same way, whenever they need to implement any AWS project, first of all, they need to start with creating an AWS account. And the user who is accessing this account, or basically the account which you create initially will be the root account, basically. We call it as a root account. And the user who accesses this root account will be the root user. The root user will have unrestricted access to access the AWS services in the root account. Okay. So the root user can access any service in this account. So initially, when you are creating an AWS account, that kind of permission is required. Right? Now, in order to log into the root account, the root user uses an email address and the password. The AWS account which you are using it, which I am using it, these are all root accounts only. But if you have a project of team 10 and they need to access the AWS services in order to work on the project. So if you need to give access to the AWS services, do I need to provide the root account credentials to the users? No. What we can do is we can use an AWS IAM service by creating multiple users. For example, I can create 10 users. So user 1, user 2, user 3. I can create 10 users under the root account only. Okay. So the user accounts are not separate accounts. They're within the root account only. But the users use their own credentials in order to log into the root account. We have a hands-on, not to worry, you'll understand it. Okay, I'm just introducing this topic. So these IAM users will have their own credentials. You need not share your root account credentials. They'll have their own credentials in order to access the AWS services. Okay. Now these users with their credentials log into the root account, okay, and behave according to the permissions which we define, like this. Assume that from user 1 to user 4, they need to access on, for example, you want to give access to EC2. And user 5 to user 8, I want to give access to RDS. And user 9 and user 10, I want to give access to S3, for example. So what I would do, I would assign EC2 full access policy to these users. So these users will be able to talk to EC2 service. The same way, I would assign RDS full access policy to this user. So these users will be able to talk to RDS. The same way, S3 full access policy to this user. So these users will be able to talk to S3. So what I can do is I can create an IAM user accounts, basically called users, and I would define the policies or the permissions itself. Policies are the permissions itself, okay? I would define the policies based on the requirement. So that these users would log into the AWS account with their credentials and behave, means they can access depending upon the policies which is assigned. Okay. Now, let's assume I created 100 users over a period of time based on the requirement. Now there is a a new requirement that these users need to access a new service, which is DynamoDB. Now what I need to do, I need to select a user and I need to assign the DynamoDB policy to these users. Now, because I have 100 users, I need to select the each and every user and assign the policy 100 times, isn't it? Which is a non-productive way of doing it. So what we can do is instead, we can create a user groups. User groups, as the name suggests, user groups are the collection of users. So for example, I can create a user group saying that sales, because maybe these users these users are from sales department, or marketing, whatever the name you can give, define whatever the name. It is wise to define the name which is relevant to the users. Okay, so I can create a user group and I would assign the policy to this group and add these users into this group. So whoever users which are in this group will be able to access the DynamoDB service. So if you need to manage multiple users, you can go for user groups. Okay, so using the user groups, we can assign a policy to multiple users at a time. And user groups is only a way where you can manage multiple users at a time. Okay, and even in real time, users alone will not have any permissions or policies. So an example could be, for example, you have 3 departments or 3 environments, I would say, like dev, prod, and test. So what I will do, I can create 3 user groups, dev, prod, and test. 3 user groups, okay, and I can add the users under this group. So user 1, 2, 3, 4, 5, 6. So we learned that users can be under a group and a user can be under multiple groups also. Maybe a team lead, maybe he wanted to understand what is happening in all the groups. So a user can be under multiple groups. Okay, we can assign a policy to these groups. So relevant policies can be assigned policy 1, policy 2, policy 3, and we can assign multiple policies to a group, not just one policy. We can assign multiple policies to a group. We can assign multiple policies to a user also. Okay, but you cannot have a user group under another user group. You cannot have group under a group, not possible. Nested groups are not allowed. Okay, so we can create a user without any permissions. You can create a user, and according to the designation or role, you can assign this user under a group, and you assign a permission to a group, like assign a policy to a group. Okay, maybe if a user 2 needs to work on prod environment, you can simply remove this user from the dev group and add under the prod group, something like that. So it is easy to manage the users with the help of user groups. Even though it is not mandated to use user groups, but it is a very efficient way. It is highly recommended, a best practice. So I can go for users and create a user. So I can just give a name as user 1. And I want to provide console access as an IAM user. And I can allow AWS to generate a password, or I can give a password. And I can allow the users to create a new password the next sign in, but in our scenario, I will be the one who would be logging into it. So I will just disable this. I can add a user to a group while I'm creating a user. I can copy the permissions of an existing user if I already have any user. I can attach policies directly. This is what we're talking about. So we have many policies which are managed by AWS. Okay. And I can say EC2 full access policy to this user. Okay. Now these policies are in JSON format. If you see, they're in JSON format. Now, if you are aware of JSON, you can create your own policy also. If you create your own policy, it is a customer managed. So the policy which is already there are called AWS managed. AWS is taking care of it. But you can also create your own policy and attach to a user group, etc. Okay. Now, as of now, I'm just assigning an EC2 full access policy to the user, and I'm reviewing it and create it. Now, IAM user login page would be different from the root user login page. So this is the console login URL for the IAM user which we created. And this is the username and password where I can share the email instructions to the user, or I can download it and share it also. Because as a root user, I'm creating an IAM user, right? Now, once I create an IAM user, I need to give these credentials to the users who need to access my account, right? So now what I will do, I will log in as an IAM user, but I will open in a private window, because if I open it in this window, my root account will get logged off when I log in as an IAM user account. So I will open the private window just not to overlap with my existing root account. So my username is user1. And then I'll give the password. Now, if I click on sign in, ideally I should be able to access the AWS account. And you see, it's very much same as the normal AWS account, root account only, but you see at the right hand side, you see it as user1 at the account ID, first thing. So second thing is, this is like a window shopping, like where you can only see, this user cannot access it. For example, this user is having permissions to EC2, right? Now let me try to access a service called RDS. Now, if I click on create RDS, you see it is saying user one is not authorized to perform. Okay, because the user is not having permissions to access the RDS. Now let's try to access a service called EC2, which the user having permissions to. So now if I click on running instances and launch an instance, it will not throw an error. I can access and I can launch an instance. If you want me to show, so I can simply launch it with default settings. Just wanted to confirm you that we will be able to access the EC2 service because the user one is having full permissions to EC2. Okay. Now let me go and create a user group. So I will create a user group, naming it as dev, or give whatever the name you want it. And you can add a user to a group while creating a group, or you can add users after creating a group also. So while creating, you just have to click on the users. After creation, I will show you. Now you can assign policies to the group now. So let me give RDS full access policy to this group. And I'm creating a group. Now I'm creating a group without any users. Okay. Now group will not have any credentials. Please understand. Group is used to group a few users. It's a collection of users. That's it. Okay. Now, basically, the user groups will be used to consolidate users so that we can give common permissions to the users. Now, the group is having no users. Now, let me add. So you just have to go to group, add users, select the user, and add user again. Okay. Now, under the group, there is a user. Now, if I go to users back again and click on the user one, the user one is having two policies attached. One is EC2 full access policy, which is attached directly Next one is RDS full access policy, which is attached through group. You see, you can clearly see that. Now the user one is having access to EC2 as well as RDS. Okay. Now I'm in the user one login page. So previously, when we tried to create a database using RDS, it didn't allow us, right? Now let's try to check. Now go to RDS. Now create an RDS. So usually it takes a while to reflect the changes. Previously, it was not like that. Nowadays, it is taking time to reflect the changes. So let's wait for the permissions to reflect. Let me refresh the whole page. So IAM is eventual consistent. Means if you update any changes, it will take a while to reflect. So let's wait for the options to reflect. Then only we will go forward. Yeah, now if you could see, maybe I shouldn't be refreshing this many times. So now this user is having permissions to database where he can create the database. Okay. So that's about the users, groups, and I also discussed about the policies. Next, we have roles. So roles have many use cases, basically. So let's assume, 1 second, please. Yeah. So let's assume I have an application on a server, and I have a database for the application, which is on RDS. Now, in order to interact with database for the application, you need to integrate two services by giving the RDS endpoint in the application logic. You need to open the firewalls relevant to it so the application, the EC2 can reach the database RDS. Okay. Now, even if you open all the firewall and given the application logic correctly, one service of AWS cannot do operations on another service of AWS. Not possible. Okay. So if the EC2 need to do some sort of operations like, a create table, create a kind of a database from the application, the EC2 cannot do it. Not only these two services, any AWS service, one service of AWS cannot talk to another service of AWS by default. Okay. So if the EC2 need to talk to RDS, you have to have a role. You have to have a role. Now, the role must have the permissions like RDS full access policy to this role so that the EC2 with this role can talk to RDS. So service to service communication can happen by having a role. Okay. Now, another scenario can be if the application need to store data to S3. Again, the application cannot do operations. Basically, the API calls you cannot make on S3 objects or buckets directly. The application which is hosted in EC2 must have a role which has S3 full access policy. Then only one service of AWS can talk to another service of AWS. Okay, now another way to use roles is communication between AWS accounts itself. So this whole thing which is happening in an AWS account. Now let's assume I have two different AWS accounts. One is dev account, another one is test account. Dev account is having a user 1, user 2, user 3. Now the test account is having AWS services like EC2, RDS, S3. Now the user 1 in one AWS account need to interact or access the AWS service called EC2 in another account. This user must assume a role in order to access the EC2 service. You have to have a policy, have to have a role which has EC2 full access policy so that a user in one account can access a service in another account. For example, I have my own account. Will I be able to access your EC2 instance in your account from my account? Ideally, it is not possible. You have to have a role. Another thing is web identity. Let's assume I ask you to sign up into xyz.com website. Okay. Now, one way of sign up is you give your first name, last name, password, email address, create it. Create, sign up. Now, another way is sign up using Google or Gmail or Facebook. You'll have an option, right? So web identity, you are actually showing that if this website is supporting this web identity, okay, now you are using the same credentials of Gmail in order to access this website. You are using the same credentials of Facebook in order to access this website. It's basically a single sign-on. Means single sign-on using the same credentials you want to access another website. The same way, if you need to access aws.amazon.com as a website, if you're having a web identity like a Google or Gmail or Facebook or any identity broker application, you can use that web identity in order to access the AWS service. For that also, you have to have a role. Okay. Next, we have SAML 2.0. It's very much relevant to the organization. So let's assume there is an organization, there are thousands of employees. Okay, each and every employee will have their own dedicated laptop or desktop where they will have credentials in order to access them, right? Username and password. Okay, username and password. Now those credentials will be stored in an active directory. So you will have active directory or corporate directory in each and every organization where they store all the employee credentials. Okay. Now, if the organization is migrating to the cloud, okay. So, for example, there are hundreds of employees. Do we need to create hundreds of IAM users? Ideally, no. Or if I have thousands of users, I cannot create user account for each and every employee. What we can do is we can federate them. So that means we will integrate their corporate directory with AWS IAM in order to access the AWS services. For example, EC2 or S3 RDS. Okay. Now, whenever the employees in this company need to access the AWS services, first of all, they will request to the IAM. Okay. Now, IAM provides STS, Security Token Service, a temporary credential. With this credentials, the employees will be able to access the AWS services. So your corporate directory should support SAML 2.0. Basically, there's an algorithm, a feature which it has to be supported in the corporate directory. If not, they have to create one. Or you can simply create a custom trust policy to enable others to perform actions in your AWS account. So a role has many scenarios where we can use it. Okay. So for now, we will go for this. If the EC2 need to talk to, for example, S3, how to create a role. Okay. So first of all, I will say one AWS service, which is EC2. I want EC2 to talk to S3. So I have to have S3 full access policy. So it's like this. Now the EC2 need to talk to S3. For that, EC2 must have a role. Okay. So I'm creating a role for EC2 and I need to assign S3 full access policy. I don't give full access. I can give read access. See, I have different ways I can assign policy. I can give read access. I can give write access. I can give full access. Okay. Now, for demonstration, I'm just giving full access to this role. So I'm creating S3 full access. I'm selecting S3 full access, and I'm giving a name like EC2 network talk to S3. Role. Okay. And I'm just creating a role. So now our role is created. Now, please understand, I just created a role. Now I need to assign this role to this instance. Okay. So here I can see this role. Now, how to assign it to the instance? First of all, I need to go to the EC2. Go to the instances. Select the instance, security, and modify IAM role. And select this. So that this instance is now can make operations, can do API calls to S3. Okay. Now you can assign a role to an existing instance, or you can assign a role to an instance while creating also. So for that, you need to go to advanced details, IAM instance profile, and here you select a role, whatever the role which you think is relevant. Okay. So that's about the IAM role. So IAM users, user groups, roles, and policies. IAM roles. Now, if you need to log into AWS account as a root user, for example, you need an email address and a password. But this email address and password would be used if you need to access the AWS account basically a console, like AWS console homepage, basically like a GUI. Okay, but we can access AWS services in different ways, right? Not only through GUI or not only through AWS Management Console. We can access in another two ways. What are they? Remember? What are the other ways to access the AWS services apart from using the GUI, apart from console? What are the other ways to access AWS services?
SDK
SDKs?
and console.
Console has already been mentioned. We have
A CLI.
CLI, exactly. Now, in order to access the CLI or SDKs, you cannot use these credentials. You cannot use email address and password. You have to have access keys. You have to have access keys. These access keys can be generated in the console only. Okay, so in order to do that, you have to go to security credentials and you have access keys here and you have to create access keys. So access keys for root user is not at all recommended, but I'm just showing you because I have to show you about these keys and create an access key. Now this is the username and this is the password. So access keys contain access key and secret access key. This is the username and the password. Very much same as username and password. Without the access keys, you cannot use it. You cannot access the AWS services using CLI or SDKs. Okay. Now you just have to copy. If I click on show here, if you could note these credentials, you can access my AWS account. Yes, maybe in different way, but you can access my AWS account. But this is I'm not showing it as I'm not clicking on show. Okay. So these are the credentials again. So don't assume that, okay, I haven't shared the username and password for my root account. So there is no way where they can access. No, there is a way which is using access keys. Okay. Now that I have the access keys created, okay. Now, if I don't save while I'm creating access keys, if I don't save the credentials while creating the access keys, okay, I cannot retrieve the secret access key. So this is the access key ID, means the username. I cannot retrieve the password. Okay. So while you are creating only, you have to save it. If you don't save, there is no way where you can retrieve it. Retrieve what? The secret access key, like the password. Okay. Now let's assume I have saved it. Yeah. Now this is active. Now that I'm using this access keys to access the CLI. So I created it. But you access the CLI or SDK once in a while, not every day. You access it once or twice in a month or a week. So whenever you are not accessing it, what you can do is you can simply deactivate it. If you deactivate, even if the account credentials are compromised, ideally it shouldn't be, okay, it shouldn't be compromised. Even if it is compromised, okay, they cannot access it because they're inactive. So whenever you're using it, you can make it active, and whenever you're not using it, you can make it as inactive just to secure it. Okay. But if you're not at all using CLI or SDKs, it is highly recommended to delete it first of all. Delete it. And whenever you want it, you can create again, not a problem. So the accesses can be created multiple times, not a problem. So whenever you're not using it, just delete it. And it is recommended not to have access keys by default. That is the reason I don't have it. Clear? Any questions, please?
No.
Cool. So now what you're supposed to do, one second, let me share my screen again. So first of all, you can just work on IAM. There is no assignment for IAM, folks. So you can just practice here itself. Create multiple IAM users, play around groups. You can create roles, okay? And you can assign these policies to the users, groups, or roles, okay? So whatever I've shown you, you can play around. You can create multiple users and you can see how it is working and all. Second thing is, there is a concept called MFA. MFA. Okay, enable MFA for root account. IAM MFA. So it's relevant to IAM service. Okay, this is a task, like a challenge, which you need to do it in the class itself. I want you to explore about MFA before I explain. So this is a simple thing. I want you to explore how we can enable MFA for the root account. So MFA is a multi-factor authenticator like an OTP. So when you're doing some transaction, money transaction, even though you log in with your credentials, while you're transferring, it'll ask for OTP sometimes when you're doing a transaction, right? The same way. When you are logging into your AWS account, if you enable MFA, it'll ask for code. So you will get to know once you explore. Third thing is a lab 5 billing alert. So here you have a guided steps. Means, so if your billing crosses $0, sorry, not equal to, greater than only. Okay. So billing is a CloudWatch metric here. So on a metric, we can create an alarm, right? So if your billing crosses $0, I want to create an alarm, a CloudWatch alarm. Okay. Now with the CloudWatch alarm, I don't want to monitor the CloudWatch dashboard all the time. I want to get an alert. So I can do that using an SMS notification. Alert to whom? To my email. I need not explicitly explain this because you have the steps with screenshots. So you can easily complete this. The options can be little outdated because it was created long back, but definitely you'll find the options. Just explore this and try to complete the Labify billing alerts document. And guys, this is mandate. For step 2 and step 3, there is no cleanup. Please enable MFA for the root account for security reasons. And billing alerts, if in case, see, now this is the last week and you may not access AWS account very frequently. Now, for some reason, if you have created few servers and you forgot to clean up, it may cost you, right? So to avoid that, you can enable this billing alert. There is no cleanup. No cleanup for these 2 steps. Okay. And the last thing is complete all pending assignments. If you still have time. All the pending assignments. Now that fortunately we have time. Okay. So complete all the pending assignments. There is no assignment for IAM or for this because it's already been with the guided screenshots. There is no need of any assignment. Okay. So the previous assignments like the EC2, the EBS, the EFS, the VPC, RDS. So if you have any assignments left, please complete them. Okay. So for today's session, there are no assignments, just a practice. Guys, please complete these assignments only when you complete 1, 2, 3 steps. Am I clear on what you need to do? Hello?
Yes.
Perfect.
Yes.
So let me create the breakout rooms. I'll keep the screenshot in the WhatsApp group, okay? Not to worry. So that you would know what you need to do. So give me a sec. Yeah. I'm opening the rooms, and give me 2 minutes, 2 or 3 minutes to update in the WhatsApp group regarding what you need to do. Okay. For now, just start with IAM, practice with IAM users groups and roles. Yeah. So please do join your rooms. Naveen, please do join your room. What happened, Akshat? Arbas, why you came to the main session? Could you please join your room?
Okay, man. Anjali? Yes, yes, I can hear, but I hardly hear you, Anjali. Can you please send a message? Sure, sure. I'll add you. I'll add you. I mean, you wantedly came to the main session, so you can only join back. So in the more, you will have options. Can you please click on it? folks. See you tomorrow. Bye-bye. Tomorrow we'll
Thank
be
you.
covering the project too. Okay? ELB and auto scaling group.
Okay, Rupama.